Hello and welcome to the Chemistry Academy. In this video we're going to go over the second half of the 2018 National 5 Chemistry paper. If you're looking for help with any questions from 1 to 8, you'll find them in a separate video on my National 5 Chemistry past paper walkthrough playlist, along with a video on the multiple choice section as well. So this video, like I said, is going to cover question 9 all the way through to the end of the paper. So if we just get started, state what's meant by the term unsaturated. So this is just a definition that you need to know, and if something is unsaturated, it means it contains at least one double carbon-to-carbon bond. Okay? If something is saturated, it means it contains all single carbon-to-carbon bonds. So my tip is just to remember S for single is the same as S for saturated. So then unsaturated would be where you've got at least one double carbon-to-carbon bond. The chemical test, including the result that can be used to show that something's unsaturated. This question, you need to be very specific with how you word it. You need to say that bromine, water or solution will rapidly decolorize. Okay, that's you including the test and the result. So bromine solution is the test and the rapid decolorization is the result. You don't always need the rapidly at National 5 level, however if you go on to do higher you will need to include it in your answer, so it's a good habit just to get into now to include it in your answer. Then calculate the energy required to increase the temperature of olive oil to 180 degrees Celsius. So because we're talking about energy here, that tells us we need to use EH equals Cm delta T. So if I like to write the variables down the side of the page and pull the numbers out of the question. It just helps me know what I'm trying to work out and where to start. So we've got calculating the energy, that's what we're trying to work out. I like to put question marks for what I'm trying to work out. And we're looking to increase the temperature to 180 degrees. Its starting temperature is 20, so this is something that catches a lot of people out in this question, is they think the temperature change is 180, but it's actually 160 because you're going from 180 up to you're going from 20 degrees up to 180. The mass is the mass of the liquid that you're heating. Normally that is water, but in this case it's the mass of olive oil that you're heating. Just remember that mass needs to be in kilograms, so you need to divide it by 1,000, so that would be 1.5 kilograms of the olive oil. And then C is the specific heat capacity of the liquid you're heating, which in this case is oil, which is why they've given you a specific heat capacity. Normally, because it's water that we're looking at heating, the specific heat capacity of water is in the data booklet. So that's 1.97, and you'll notice it's in kilojoules per kilogram per degree Celsius, which is why we need the mass of the liquid that we're heating in kilograms. Now we've got all those numbers, we can plug them all in. So we have 1.97 times 1.5 times 160. So we put that in to the calculator. 1.97 times 1.5 times 160, that gives us 472.8. And that would be in kilojoules. You don't need to put the units because they are given in the question, but if you do put them, they need to be correct. So maybe just double check what they are in the question if you're going to put them at the end of your answer. Balancing the equation. So the easiest way to balance the equation normally is going from left through the elements from left to right. So if we start off with the nitrogens, there's 2 on the left and only 1 on the right. So we need to multiply this by 2. So that gives us 2 and 2. Then we move on to the hydrogens. We've got 2 on the left and we've now got 6 on the right because 2 times 3 is 6, which means we need to times this H2 by 3 to get that up to 6 as well. And then that's us all balanced. What this symbol means on a reaction, most people know this, it means it's reversible, so it can go both ways. So you just need to say that it is reversible in terms of what it indicates. Then drawing a diagram showing all outer electrons to represent a molecule of ammonia in NH3. So we need a circle for the nitrogen that's in the middle, and then 3 circles for the hydrogens around the outside. Then in each overlap bit we end up with 2 electrons. So got 2 in there, 2 in there, and 2 in there. One has come from each of the atoms, so hydrogen gives its 1 electron, and then nitrogen has given 1, 2, 3. If we have a look at how many outer electrons nitrogen actually has, it should have 5. So we've drawn 3 of its outer electrons in already, so that means it's got 2 left over, so we put them in as a pair. Hydrogen only has 1 outer electron, or 1 electron in total, so once you've drawn the 1 electron for hydrogen in the bond, there's no more to draw in for the hydrogen. The industrial process used to convert ammonia into nitric acid. Nitric acid is produced in the Ostwald process. Spelling of names of processes and chemicals is very important, so make sure that you know how to spell these sorts of things. And then ammonia reacts with nitric acid to produce a salt. Name the salt produced in this reaction. So if you've used ammonia as your base, your alkali, the salt will have ammonium in the name. Okay, it's actually on page 8 of the data booklet. If you do forget how to spell it, you will find ammonium here. Okay, so ammonium, and then if you've used nitric acid, your salt name will end in nitrate. If naming salts is something you struggle with, you can go and check out my video on neutralization, and you can skip to the part on naming salts in that, and then hopefully that will help you, because the name of the salt is very dependent on what you've used to create the salt. Again, spelling is very important with the chemical names, so just make sure you double check your spelling. On the diagram, show an arrow to show the path and direction of electron flow. So remember, the electrons always flow through the wires, never through the solution, and they flow from high to low. When we say high to low, we mean from higher in the electrochemical series to lower in the electrochemical series. Our cell had copper and magnesium in it. Magnesium's up here, copper is down here. The magnesium's higher, which means the electrons will go from the magnesium to the copper through the wires. So we just need to draw arrows going in the direction from the magnesium to the copper on the wires. Explain why an ion bridge is used to link the beakers. The ion bridge is just used to complete the circuit. That's all you need to say to complete the circuit. Don't say to allow conductivity of electrons or to allow conductivity of electricity, because like I've just said, the electrons go through the wires. So it's actually the ions that go across the ion bridge, which they carry negative charges, so that allows for the circuit to be complete, but they're not actually carrying the electrons, so just be very careful. And the best thing, like I said, to say is just it completes the circuit. In this reaction, the copper ions are reduced. Remember, reduction is gain of electrons, so oil rig. So something's gaining electrons. Write the ion-electron equation for the reduction of copper 2 ions. You may wish to use the data booklet to help you. So if we go to the electrochemical series, because that's where oxidation reduction things are, and it tells you at the top here that these are reduction reactions. So that reminds you that from left to right, it's a reduction. We're looking for the reduction of copper 2. So if we go down and look for copper, we can see here there's copper 2 there, and that's the equation then that we want to copy out. So we would have Cu2+. You don't need to put the state symbols, but if you're copying them, you might as well, plus the 2 electrons going to copper as a solid. Okay, so it's easy as that. If you needed an oxidation, you would just be writing these equations backwards. So you would say you were asked to write the oxidation of aluminium, then you would find aluminium and you would just write the equation back to front. So you would have the aluminium, you basically swap the sides. So the aluminium solid would be on the left, and then the aluminium ions and the electrons would be switched to the right. For 11D, suggest why a magnesium phosphate would not be suitable in the cell instead of the magnesium sulfate. So in here, the magnesium sulfate is a solution. It's an ionic solution, which means it can work as an electrolyte. So electrolytes are ionic solutions that can allow for conductivity. In order for ionic substances to conduct, they need to be able to be made into a solution. This tells us that we want to use the data booklet to help us, and the bit of the data booklet we actually want to use is the solubilities table. So if we look at magnesium phosphate, we should be able to see it's insoluble. That means you can't make an ionic solution from it, which means it will not conduct electricity. So the reason that it's not suitable is because it is insoluble in water. Okay, so it would not act as an electrolyte. Okay, so just remember, an electrolyte is just an ionic solution that allows for conductivity. The reason why a radioisotope which emits alpha particles is not suitable to measure the thickness of paper is because the alpha particles would not travel through the paper. They are stopped by paper, so they wouldn't be detected. So see how the radiation's coming out of the source through the paper and then being hit by then hitting the detector. If that was alpha, it would just stop at the paper. So all you have to say in terms of the reason is that it is stopped by paper. Then we've got a half-life equation calculation. So it tells you that a paper manufacturer found that thallium-204 had only 1/16 of its original activity. It tells you what the half-life is, it's 3.7 years, and you're asked to calculate how old the source is. So for all the half-life calculations, you usually want to first of all start off by trying to work out how many half-lives have taken place. In this particular question, we know how much is left, like what fraction is left, so we can work backwards and work out how many times it had to consecutively half to get to 1/16. So the 1/16 would have been beforehand an eighth, which would have been before that a quarter, which would have been before that a half, which would have then been the whole. Each half-life was an arrow, so then we just count how many arrows we've ended up drawing. That's 4. So that means we know now that we've undergone 4 half-lives. That then allows you to work out how much time has passed, because you know that one half-life was 3.7 years. So for 4 half-lives, we just need to times that 3.7 by 4. So when we do that, 3.7 times 4 gives us 14.8, and that would be 14.8 years. Okay, so for all the half-life calculations, try and start off your calculation by working out how many half-lives have actually taken place. So then the question here is asking when an atom emits a beta particle, the atomic number of the atom, what happens to it. So beta particles, remember, are just electrons. They have a mass of 0 and the atomic number of -1 when written in nuclide notation. So this means when you emit a beta particle, the atomic number actually increases by 1. So the particle that's being emitted has a -1 atomic number, which means whatever has been left behind must end up with +1 on its atomic number. So the atomic number increases, but the mass number stays the same because the beta particle doesn't have any mass at all. Okay. Knowing how atomic and mass numbers change based on the type of radiation emitted is a really useful thing to know. So you can go and check out my nuclear chemistry video if that is something that you're not sure of. Hopefully that will help. The functional group in this molecule here, that is a carboxyl group. Okay, because it's the C double bond OOH, that's a carboxyl. The mass of 1 mole of the malic acid, that's essentially asking you to work out the gram formula mass, so you really need the molecular formula. So if we count the carbons, we've got 1, 2, 3, 4 carbons, so C4. The number of hydrogens, 1, 2, 3, 4, 5, 6. And then it's got 1, 2, 3, 4, 5 oxygens. So then you just want to add that up. So 4 times the relative atomic mass of carbon, which is 12. So 4 times 12. Then 6 times the relative atomic mass of hydrogen, which is 1. You'll probably know all these ones by the time you get to the exam. But if you don't, it doesn't matter because they're always in the data booklet anyway. And then oxygen is 16. You see it there, so that'd be 5 times 16. So then if we add all that up, so 4 times 12 plus 6 plus 5 times 16, 134. And that's the mass of 1 mole of it, because that's the GFM. Again, you don't need to put units because they're given in the questions, but if you do, you would just have to make sure that you gave the units as grams. If you gave the wrong units, then you would get a mark taken off. So then a problem-solving question here. Carboxylic acids can contain a halogen atom. The pH of 1 mole per litre solutions of some of these acids are given in the table. Describe how the acidity of the carboxylic acid is related to the position of the halogen in group 7 of the periodic table. So for these questions, this is where it's very important to use the words that it's giving you in the question. So it's asking you to say how the acidity is related to the position of the halogen. So if we look at the position of the halogen, they're in a random order. So if we look at the halogen group, which is this group here, fluorine's at the top, and then it goes chlorine, bromine, iodine. So let's number these 1, fluorine, chlorine, bromine, iodine. So then if we look at how then that affects, so as you go down the group of the halogens, the pH is increasing. However, they've asked about the acidity. So remember, a lower pH means it's more acidic. So actually, as you go down the group of the halogens, the acidity of the carboxylic acid decreases because the pH is getting higher, so it's becoming less acidic. So that's how you would want to phrase your answer. You could also say as you go up group 7, the acidity increases because the pH is decreasing. So just be very careful in your wording of these trend questions. Make sure you use the words in the question and you really think about what those words mean. Then another problem-solving question. You've got a reaction here. So they've shown you an example of a reaction called the Jones oxidation reaction, where you can convert alcohols to carboxylic acids. And then it tells you that the following alcohol can also be converted to carboxylic acid by the Jones oxidation reaction. Draw a structural formula for the carboxylic acid produced in this reaction. So what you want to do with these questions is have a look at the example they've given you, and imagine your friend has got this picture on a whiteboard and you've got to give them instructions of how to convert this molecule into this one. So say like my first instruction would be remove one of the hydrogens, remove the hydrogen on the C with the OH, and then that's be the first instruction, and then once they've done that, add a C double bond O, and then they also need to remove the other hydrogen, so they technically need to remove both hydrogens, so we'll just say both H's from the C with OH. So then what we do is we look at our new molecule, which is usually a more complicated molecule, but we just still follow those simple instructions. So if we look at our molecule, we're removing both hydrogens from with the carbon that's got the OH, so that's these two, and then we add a C double bond O there instead. So then that would be our molecule. So all we have to do is just copy down what we've just drawn. Okay, and it makes it so much easier. So if you just write down those really simple steps, so like I said, imagine your friend's got the molecule written on a whiteboard and they can rub stuff out and add stuff in. You just need to really basically explain to them how to do it. Okay. So then for question 14, chloride ion concentrations greater than 0.25 grams per litre can cause a noticeable taste in drinking water. The tablet gives information about the chloride ion concentration in drinking water from different sources. One of the sources provides drinking water that does not have a noticeable taste. Identify this source. So it tells you that if the concentration is greater than 0.25, it will have a noticeable taste. So we want the one that's lower than that, which would be source B. Source C. Can't read. Then we've got a titration. So a student investigated the concentration of chloride ions in drinking water from another source. Samples of water were titrated with silver nitrate solution. An indicator was used to show when the end point was reached. Name the most appropriate piece of apparatus to measure 20 centimetre cubed samples of water into the flask. So if we're measuring out any samples, the best thing to ever use is a pipette. If you don't have a pipette of the exact volume that you need, then the next best thing is a burette. Never suggest measuring out volumes of liquids using measuring cylinders or beakers, although I know that's what you used to do all the time in first, second and third year. It's not accurate at all. So pipette is the best thing, but if they're telling you the pipette is of the wrong volume compared to what you need to measure, then the next best thing is a burette. Then the average volume of silver nitrate that should be used to calculate the chloride ion concentration is 8.05 centimetres cubed. Explain why only the results of titration 2 and titration 4 are used to calculate this average. So if we look at the results here, they've only used 2 and 4. That is because they are the only concordant results. So remember, concordant results are the ones that are within 0.2 centimetres cubed of each other, and they are the results that we need to use in titration calculations. So because they are the only two concordant results, they are the only ones that are used. In terms of how you explain this, the best thing to say is that they are the only concordant results. If you phrase it any other way, it's not guaranteed that they'll give you the mark. If you have a look at the marking scheme, it does tell you the things that they won't accept, like they won't say because they are the closest together or because they're the most accurate. You are really better to use the word concordant if you can remember it. So then part 3, calculate the number of moles of silver nitrate in 8.05 centimetres cubed. So if we take the numbers that we've got here out of the question, we were asked to calculate a number of moles, so I'll put n equals question mark. We've also then got a volume, so volume equals 8.05 centimetres cubed. If we go and have a look at what the picture tells us, we've got a concentration of silver nitrate, 0.02. So then we should be able to see that we can then use NCV to work out the number of moles. So we do N equals C times V. That equation is at the front of the data booklet if you do need it. Just don't forget to change your volume into litres, so you need to divide that by 1,000. So the concentration stays as 0.02. The volume becomes 0.00805. So if we put that into our calculator, 0.02 times 0.00805, that should give you, and you can keep it in scientific notation if your calculator gives it to you in that way, 1.61 times 10 to the minus 4, or you can write it as a normal number, 0.000161, and again that is moles because they've told you to calculate the number of moles. Again, you don't need to put the units, but if you do, they need to be correct. So if you were to write like moles per litre or something there, you would get the mark taken off you. We'll just skip to the actual question before we go back to the passage. So the name of the apparatus used by researchers to create high pressure. So you want to kind of pick key phrases that they've used in the question and try and find those phrases in the passage. So they've mentioned high pressure. So again, a piece of apparatus called a diamond anvil cell. So that would be the answer there, diamond anvil cell. Then calculate the pressure in atmospheres when sodium is squeezed 190 gigapascals. So there must be some information about pressure. So if we have a look, that diamonds can reach 1,000 gigapascals, which is a pressure of 10 million atmospheres. So we are asked to work out the atmospheres of 190 gigapascals. So this is actually a numeracy question. So they've told us that 1,000 is 10 million atmospheres. So we're going to write that as a numerical relationship. I'm just going to write 10 million as a number rather than, as words rather than as a big long number. And we're wanting to work out what it would be for 190 gigapascals. So we first of all go down to 1. So that would be 10 million divided by 1,000. and then we scale up to the 190. So it'd be 10 over 1,000 times by 190. The million just then means that that's going to be, the number you get out is going to be in millions. So if we work out that answer, 10 divided by 1,000 times by 190, so that's 1.9, and that'd be million. And again, it'd be atmospheres. Because the units are given to you in the question, again, you don't need to write them, but if you do, just make sure they're correct. Suggest what would be observed if this pressurized sodium was placed in the circuit below. This circuit is assessing conductivity. So if we look, there must be something in the passage that tells us about the conductivity. What's happened there? So when sodium is squeezed to 190 gigapascals, it loses an important property of metals and becomes an insulator. So if it's become an insulator, then it means it's not conducting. So it means that in terms of what would be observed is that the bulb would not light up. Okay. Again, it's important to read the question and make sure you can see what they're actually asking, because some people might say it wouldn't conduct, but that's not saying what you would observe. So the bulb would not light up is what you would actually see. Then write an equation using symbols and formulae to show the decomposition of iron 3 oxide at high pressure. So again, we go back to the passage, look for the decomposition. So if we have a scan, here we go, there's the word decompose. So it says, iron 3 oxide decomposes, releasing oxygen and forming the very unusual Fe5O7. So that's our product, the oxygen and the Fe5O7. So we've got oxygen, which has to be written as O2, then Fe5O7, and the iron 3 oxide is the reactant. So we just need to work out using SVFDF what that formula actually is. So iron's valency here is 3 because there's a Roman numeral 3. Oxygen's valency, it's in group 6, so its valency is always 2. So then if we swap them over, it's 2 and 3. You can't simplify that, so then that means it's Fe2O3. So you just write that there, and that's you. You don't need to balance it or anything, so that's it. Question 16. Thiols are a family of compounds containing carbon, hydrogen and sulfur. They have the same general formula and similar chemical properties. State the term used to describe a family of compounds such as the thiols. So groups of molecules with the same general formula and similar chemical properties are called homologous series. Suggesting a general formula. For these questions, the best thing to do is to write the molecular formula of the examples you're given down the side or underneath them. So just count up the carbons, hydrogens, whatever other atoms are there, and then that helps you work out then what your general formula will be. So all the general formulas start off with CnH2n as a basic starting point. So then you just need to look at the examples you're given and see how they fit the CnH2n. So if we look at just the C2, if we were to times the number of carbons by 2, that would give us 4 hydrogens, but we need 6. So that means we need to add 2 extra on top of that. If we then just check it for the other ones, 2 times 3 is 6, so plus the 2 would give us the 8. And then 1 times 2 is 2, plus the 2 extra would give us the 4. Then all you have to do to finish it off is any additional atoms that are there, just put them on the end. So they don't need to have any ends or anything in them, you just stick them on the bottom. And that's it. So then ethane thiol can react with oxygen as shown. You've got ethane thiol, oxygen, and it's showing you making carbon dioxide and water, and it's asking you to work out what Y is. So if you have a look at what elements are in ethane thiol, remember when you burn stuff, every atom in it will react with oxygen to produce something. So you've got carbon dioxide, which is made when the carbon reacts with the oxygen, water, which is what's made when the hydrogen reacts with the oxygen, When the sulfur reacts with the oxygen, you would make sulfur dioxide. And remember, that's the gas that's really bad for causing acid rain. So you shouldn't really be burning stuff with sulfur in it if you can help it. For 16C, you're asked to calculate the mass of methane thiol. So we know the methane thiol is this one here. Because of the last question, we can see it's CH4S, or the CH3SH that's written as here. So calculate the mass of that when 640 grams of methanol reacts completely. So this is methanol here. So again, mass is 640. Writing the numbers and question marks above the chemicals helps you work out which chemicals you need to use for your calculation. So then if we write down their formulas, and then both of them are masses, so it's going to be NM, GFM underneath both. You can do this by the proportion method. If that's the way you do it, just make sure you end up with the final answer that I end up getting here. So 640 grams, question mark, and then the GFMs of these, we need to work them out. So for the methanol, that's 1 carbon, so that's 12. The 4 hydrogens, which would be 4 times 1, so that's 4, plus 16 for the oxygen, so that's 32 grams. The ethane thiol, 1 carbon, which is 12, 4 hydrogens, which is 4, and then sulfur is, I think it's 32, but we'll just double check. Sulfur, yeah, it's 32, so add 32, and that gives us 48 grams. So now we can see we can work out the number of moles of methanol. So N is M over GFM. So you'd have 640 over 32. So that gives us 20 moles. We then look at the mole ratio to move across. So it's a 1-to-1 ratio. So moving across, you have 20 as well. You can't move across without a mole ratio, so make sure you double check what that is. And then now we've got the number of moles, we can work out the mass, because M is N times GFM. So that'd be 20 times 48. So that would be 960, and that'll be in grams. And again, it tells you calculate the mass in grams, so just make sure you put the correct unit if you're going to put it. And then the last question of the paper, open-ended question, everyone's favourite. Using your knowledge of chemistry, comment on the chemistry of methacrylic acid. Both of the open-ended questions in this exam are very vague, which is good and it's not so good, as I've said in the previous video if you've watched it. So what you want to look at here is like things that you notice in the molecule that are familiar to you. So like, are there any functional groups? So you can see that there's a carbon-to-carbon double bond. That means it's unsaturated. Talk about what unsaturated means. How do you test for unsaturation? You use bromine water and it will rapidly decolorize. So that would happen when methacrylic acid reacts with that. You could then draw products of addition reactions. So you could draw the bromines added across the double bond. You could draw hydrogen added to it to make it saturated. You could show the addition reaction with water, which would end up adding a hydroxyl group onto it. Then we've also got the carboxyl group here. So that makes it, could be classed as a carboxylic acid. That means it would have a pH of less than 7. You can then go on to talk about, anytime you mention pH in open-ended questions, make sure you put in about the ion concentration. So it would have a solution of that, would have a higher concentration of hydrogen ions than would hydroxide ions. You could then talk about if you were to dilute the solution, then the pH would increase and the concentration of hydrogen ions would decrease. Because it is an acid, it would then be able to react with a base in a neutralization reaction, so you could form a salt and water. So yeah, there's quite a lot to talk about here. Other things, you talk about the chemistry, it's a covalent molecule. Covalent molecules tend to have lower melting and boiling points because they have weak attractions between the molecules, i.e. intermolecular attractions. What else? Solubility. it's quite a smallish molecule, so its solubility wouldn't be too bad. Remember, for you guys, the bigger the molecule, the less soluble in water it will be. You'll find that that's different if you go on to take higher. But for this year, that's the rule. The bigger the molecule is, the less soluble it is in water. I'm trying to think. Oh, you could talk about the fact that it's got covalent bonding in it. So there's shared pairs of electrons between like the carbon and hydrogen atoms, etc. I'm trying to think what else. There's maybe potential other possibilities. Just trying to think what they might be. In terms of it being an acid, you could talk about reacting with metals that react with metals. So remember, all the metals higher than hydrogen in the electrochemical series will react with acids. Yeah, maybe you've thought of some other things. If you did, drop them in the comments. Yeah, so hopefully that helps. Just remember, when it comes to open-ended questions, it really is just a regurgitation of as much of your summary notes as you can get in there. And try and remember, and just look for one thing that you can even start off with, and then just write that down, and then think, right, how can I expand on this? How can I expand on this? And just take it as far as you can. Just expand as much as you can, and then that helps show that you've got a deep knowledge of chemistry, and then pick another thing that you can expand on, and then that helps to show that you've got a breadth of knowledge as well. And that should hopefully help you get the 3 marks. So that's that for this paper. I hope your studying is going well. Good luck for the final exam when it comes. And yeah, don't forget to subscribe. I'll see you again soon.